So in question 5, we're investigating the motion of falling masses by measuring the time taken for empty cupcakes to fall from a window. So a student drops 1 cupcake, and then 2 cupcases, and then 3 cupcases. So name 2 measuring instruments that would be needed for this investigation. Well, I've just highlighted there the time taken. Obviously that's important, so we need to use a stop clock or a stopwatch for using that. Now, he's talked about cases stuck together. Okay, so what might we be measuring there? Well, one thing might be the mass, so an electronic balance or weighing scales is really what we're after there. Now, what are the dependent and independent variables in this investigation? Now remember, the independent variable is what we're going to change. So in this case, we're looking really for the mass of the cases, okay, the combined mass, 1 case, 2 case, 3 cases. The dependent variable is what we measure, and we're going to be measuring the time taken. Alternatively, instead of mass, we could say the weight, or we could have written just the number of cases there. State 1 factor that students should keep constant. This is one of my control variables. Well, the drop height is going to be the most obvious one. But obviously any other factors that could affect the experiment need to be kept constant. So the effect of things like wind on the experiment, maybe we could do it indoors to try and get rid of any factors like that. Student choices table to record results. Suitable headings. Well, we're going to be looking at our independent variable, our mass in grams, or we could write our weight, but obviously that would have to then be in newtons, and then our time taken, which is going to be in seconds. Now, so state 1 way that the student can improve this investigation. Now, there's a number of things we could write here, okay? One is to try and get rid of, as much as we can, the kind of error due to human reaction time. Now, the best way to do that is to make the time period longer. So the way of making the time period longer is to drop from a large height. Okay, and that reduces the percentage error in our result. Now, lots of you mentioned repeat readings, which is also okay as long as you say that you take repeat readings and calculate an average, okay, to improve the reliability. Now, the student notices that the cases accelerate at first and then fall at a constant speed. The arrows in the diagram shows the size and direction of the forces acting on the cases. Label the forces in the middle diagram. Now, our downward force is weight. Now, on the mark scheme from when this was on GCSE paper recently, said that it would not accept gravity. Okay, so in the past it has been accepted, but we would like you to use weight every time. And our force here, this is going to be either drag or air resistance, not lift, not upthrust. And the next part says, explain why the case accelerates and then falls at a constant speed. Well, I'm going to look at the mark scheme to help answer this. Now, there were 3 marks, and they're accepting anything along the lines of the following 4 things. So, if you've said that to begin with there is an unbalanced force, okay, or that the weight is greater than the drag to begin with, and we're talking about at the start here, okay, then you get a mark. So mark for saying that at the start there's an unbalanced force. The weight is greater than the weight. Now, going with that, we're going to say that this causes acceleration. So our resultant force causes acceleration, basically from our F equals ma, that if we've got an unbalanced force, we will also have an acceleration. Now, later on though, near the bottom, okay, we're going to have balanced forces. Okay, or the forces are equal. So if you've stated that later on the forces are balanced, you'll get a mark, and that if the forces are balanced, there is no acceleration. So any of those 4 points, they're going to give a mark for.